In this video, I am going to be discussing the use of std thread class, and I will be demonstrating how to use multiple threads to compute average value of very large size array. Let me go get right into the coding for this. Here I need to include thread class to create thread objects. Let me have a tax put as a function to compute average. The name of the function, it is to receive an array, integer type array, and size return type void, and I will use the reference parameter to be used to return the average value. So average value is going to be double type, so double type avg, and avg is going to carry the average value to be computed, initialize to 0 in the loop. Inside the loop, add all the elements, and finally you divide by the size. So this is the function which computes the average value of the elements of the array, and writes that in this parameter so that it can be accessed from the point from where this function is going to be called. This is a tax which is going to be executed by multiple threads. So I need to prepare data for this first. Create data. So let me have a constant size, say 500,000. Let me make it 5,003, not exactly 500,000, but a little bit 3 more items. Array of this same size, I want to populate this array with random values. So for each, and first address of the first element, address of the next address after the last element, here I'm going to place the lambda expression. So lambda expression will receive integer type as a reference, because we need to make changes to all elements if we want to set a random value to it. X equals to percentage 100. So random values ranging from 0 to 100. So for this for each algorithm to work, we need to include algorithm library, and what else is error? Yeah, I think it should be okay in a moment. Algorithm library. Yeah, with this we have data ready, and I want to display data to the standard output. So maybe samples of this array. It's not possible to display all 500,000 elements on the screen. So let me take 10 initial sound, 10 first 10 elements of the array. To first element to element with index 10, and send it out to OStream iterator for integer type data and parameter cout and the delimiter. I want to separate the printed out items by comma. To use this OStream iterator, you need to include the library iterator. right? And if I want to print out the last 10 elements in the array, then I would put it out like this: size minus 10 and up to size. So this is going to be the way. And I also want to put out in different lines, so no, I think we should put string here if I want to remove that error. So this should display first and last 10 elements of this array. Let us see. I want to make sure that the array is populated with the random elements. So compile the code. There's a problem with the typing, so let me go back and fix it quickly. Here, let me make it size t. Now the data item displayed out 83, 86. This is we can consider this as random, ranging in the range from 0 to 100. Now let's dive into the actual the problem that we're going to solve. The problem is to compute the average by using threading. First, I want to compute using only one thread, and then I will compute using 4 threads. Right now, for that, to compute for only one thread, you can use the main thread or you can use a child thread. So let me use the main thread itself. Let me create the variable to hold the double the average value, and call the function, pass the array and size and avg. So avg will actually get the average value that is computed by the function. So this is going to the average. This statement will actually should display the average value computed by calling the executing the task from the main thread itself. Compile and link and execute. Now this was displayed. Actually, I want to display in different lines. So let me do some changes in the code at this point. So let me compile it again. So now we can see average 49.492. Okay, this was average computation using only one thread. If I want to compute do the computation using 4 threads, then what I have to do is this array. This array has elements 500,000. I want to divide this entire 500,000 into 4 units. Right? If you divide 500,000 into 4 units, it would be 500. If you divide it by 4, it's going to be 1 5 150,000, right? Each should carry 150,000, but or approximately 150,000, but we have 5,003. So it's not possible that you can have all the sub arrays divided. I mean, the subset of the arrays of equal length. So you need to be careful about that as well. If it was 500,000, then it would be all the array would be all the area of the all subdivided the size of the all the subdivided array would be 150,000, but it is 500,000 plus 3. So we need to be careful about. I will show you how to do that in a moment. First, I want to compute the size of the divided smaller array. So size t and size let's say sub, let me call it size sub for sub array equals to size divided by 4. So if you divide by 4, it's going to be, I think it is 150,000. Let me see what value it comes out to. Let me show you the screen. So I did when I did in the meantime, what I did was you need to divide the entire array into 500,000 array into 4 sub arrays, and if you divide the size by 4, you will get it's going to be, let me display what is the value. So it is 125,000. Okay, this is 125,000 actually. Maybe that this was a little bit incorrect. So this was 125,000. So now if you multiply 125,000 by 4, it's going to be 500,000. It's not going to 500,003, right? So we need to be careful about that. So let me remove this part here. Now I want to create a thread T1 to compute average for the first 125,000 elements of the array. So the tax I want to pass to it is average, and the array I want to pass is the beginning, the first array, the beginning of the array, and the size is going to be size sub, right? Therefore it will start processing from the first element of the array, and it will continue processing up to this number of elements. That's 125,000 elements. In the second thread, same tax, but the array beginning of the array is going to be the element with this index, right? So but actually when you pass array, we have to pass the address of the array, not array element. So address of array followed by the same size. And another thread T3, tax same, and my ARR. In this case, I'm going to pass the address of the element which is at twice of size sub. So 2 times I need to pass address. And for the fourth thread, same tax. If I pass address of the next subset or subset, but if I pass size sub, it will not incorporate all the elements, because it will most probably leave out this last three elements. So I need to do it something like this: size minus 3 times size sub. I think this will actually incorporate all the remaining elements into this computation. Now we also need to pass average in all these threads. So let me create 4 average variables. 1, and pass those variables into the thread. So these 4 variables will carry the average of the first part, second part, third part, and fourth part. Now but since if I run it, it will run into a problem. After, let me compile it first, and I will show you afterwards. Okay, what is the problem? I'll explain you. I will keep it the way it is now. I'll come back and fix in a moment. Now after that, I would like to join all the arrays. So I think this should be T4 synchronization process. Now when you compute the overall average, it's going to be this is average for size sub number of elements. So first you need to compute total, not the average but total summation. So you can do that by multiplying average 1 by size sub plus total for the total computed through the second thread plus avg4 times, in this case the same size we have used here. We have to use this entire expression, avg4, and you divide entire stuff by total size of entire array. Right, this is how you compute the average of the overall array based on the average of individual sub arrays. So let me so what I have done here is created a thread, pass average as the tags, and pass the array, the address of the first element of the sub array I want to start processing, and the total number of elements following from that point, and the variable where I want to write the average into. In the second thread, I'm passing the address of the element from where I want this thread to start processing, which is going to be this element, and this is going to be to the size, and average 2 is the variable where I want to write average, and twice sub size and size and average I want to write into. And in this case, this size is going to be the expression, right? If I use only soft size, it will probably omit this last 3 elements. So if you subtract from 3 times soft size from size, then that expression will actually make this thread to incorporate all the remaining left elements to compute the average. Now this is the process, synchronization process, and this is the way I compute the average of overall array. Right, first multiply the first average by the size, corresponding size, and second average by corresponding size, third average by corresponding size, and fourth average by corresponding size, and do the summation and divide by size. This is the average, the expression I have used to compute the average of the entire array. Now I'm going to be compiling it. It will run into problem. The problem is that, let me try to analyze it. So there's a it is actually the problem is on line number 39. Line number 39, and it says that it is complaining with this double reference type. So if you want to use the reference in the code when creating thread, then you need to explicitly call the function to get the L value reference of this function, this variable. So you need to pass this as a outcome of reference function invocation. Just remember, if you have a reference in the in the tags, you need to pass something, then you need to pass the corresponding argument as a reference. So we have this code now. Going back to the terminal again, compilation, linking. Now it compiled without issue. Now when I run, the value computed is the same, exactly same. Okay, right, for 49.142, 49.492, and 492. Back to the code again. If I had not considered this this size, and put out only soft size, and it would probably not be the correct output it will computed. So if I simply use soft size, divide into equal, you use this constant size for all the sub elements, then it will lead to the problem. You need to be careful about those things when you actually. Now we can see the difference, 492, 4917. Okay, but in the same situation, if I have the total size is perfect 0, then should not be issue in this case. Again, one more time. So now you can see the output is precisely equal. Coding. So this is the end of the video. Thank you.